I decided to repeat again a simple method of analysis that eliminates one by one all the others that do not have certain characteristics. Many times it happens to me that I simply establish a cubic crystal composition or a higher specific gravity and realize that I have spinel or sapphire and not musgravite. To explain how I found the courage to announce that this is musgravite, I will explain how the whole process that leads to the conclusion works. The first is the hardness measurement in order to eliminate smoky quartz that does not exceed the value of 7, and then separate all crystals with a hardness of 8 to 9. The first is Beryl/Pezzotaite, 7.5 to 8 hardness and is cubic, which means that there is no birefringence of light. Spinel is also cubic and birefringence is absent. In the video, you can clearly see that some of the inclusions on the opposite side of the crystal show double, and when the crystal is moved, it is even better to see. Topaz does not have that color and has a much lower specific gravity. Rhodisite/Londonite is also cubic isometrically, which means that there is no double refraction of light. The play of light is very similar to Chrysoberyl. Chrysoberyl has the chemical formula, Beryl-2O4. And musgravite, Mg3Al8BO16. Aluminum, beryl and oxygen are common, and musgravite also has magnesium, only unlike Chrysoberyl. The glow and inner energy with the entrance of light into these crystals is easily recognizable to me because it is exceptional and beautiful. Chrysoberyl has star-shaped doubles and is 3-wedge-shaped. Specific gravity, Sg Chrysoberyl has a specific gravity of about 3.70 to 3.73. Musgravite is lighter, with Sg around 3.29 to 3.37. Crystal system and birefringence, Chrysoberyl is orthorhombic, optically positive. Musgravite belongs to the trigonal/hexagonal system, uniaxial, with distinct birefringence. Color range, Chrysoberyl is usually yellow, yellowish-green, brown, or alexandrite that changes color. Musgravite usually appears in grayish-green, gray, purple, or violet shades. Bahionite and bromellite, beryllium oxide, do not occur in this color, and to distinguish sapphire from musgravite, you must measure the differences in hardness, density, specific gravity. Key differences. Hardness, Mohs scale sapphire, corundum, is extremely hard, with a rating of 9 on the Mohs scale. Musgravite is softer, with a rating of 8 to 8.5, meaning that sapphire can easily scratch musgravite, which is my basic test. Specific gravity, density, is only a complete confirmation because sapphire is much denser, with a specific gravity of about 4.0. Musgravite is lighter, with a specific gravity ranging from 3.29 to 3.37. These are all minerals that are in that hardness zone, which I measure very precisely thanks to a well-adjusted hardness tester, and by comparing different crystals, I get a true insight into the hardness of the crystals. Here you can clearly see that the scale shows that this crystal is between 8 and 9 hardness according to Mosh. In this analysis, it is very important to establish the hexagonal crystal composition due to the difference with Spinel crystals, which have a cubic crystal composition. You can distinguish a cubic crystal system from a hexagonal system in a stone by examining the external geometric shapes, interfacial angles, and optical symmetry of the sample. Visual and geometric differences. Cubic, isometric, system. It is characterized by 3 axes of equal length that intersect at a right angle of 90 degrees. Common shapes include cubes, like pyrite or halite, octahedra, 8-sided double pyramids, and dodecahedra, 12-sided stones. The sides are square or triangular and always meet at right angles. Hexagonal system, characterized by 4 axes, 3 equal horizontal axes that intersect at 120 degrees and 1 separate vertical, axis that is perpendicular to them. Common shapes include hexagonal prisms that often end in pyramidal tips, like beryl/emerald. Cross-sections exhibit a distinct hexagonal, 6-sided, symmetry. Note, closely related trigonal stones such as quartz also belong to this family and exhibit 6-sided shapes, but their growth tips or internal symmetry repeat differently. Refraction of light is a fundamental element in crystal recognition, optics, and I am very attracted to the internal energy of light that a crystal actively emits when illuminated. Cubic stones are monorefractive, isotropic. Light passes through them as a single ray, meaning they have only one index of refraction and no birefringence. Hexagonal stones are birefringent, anisotropic. They split light into two rays, which can be observed with a gemological polariscope or refractometer. Cleavage and refraction. Cubic crystals exhibit perfect cubic cleavage, refracting cleanly along flat 90-degree planes. Hexagonal crystals do not break into uniform cubic blocks and often lack clear cubic cleavage. If you can share what a stone looks like, such as the number of sides, color, or whether it has flat crystal surfaces, this can help you understand its specific crystal system. However, any anisotropic crystal, e.g., hexagonal system, will change from light to dark every 90 degrees of crystal rotation, with one interesting exception, providing a reliable 30-second test that separates cubic spinel from hexagonal topaz, both of which probably have the same light density and hardness. But this is not necessarily the case. Some topaz specimens show an anomalous birefringence response between crossed filters that is typical of isotropic, cubic, crystals where the chemistry of a particular piece is such that, as the crystal formed, mechanical stress was locked into its lattice. Of course, some stones show an anomalous response under a polariscope, but this does not necessarily require you to choose the optic axis, i.e., the direction in which the iridescent colors are seen between the crossed polar lines, in which case conoscopy could still be used. Birefringence is the result of all this theory, but you have to know the theory. My intention is to show how difficult it is to identify musgravite, now known as magnesiotaphyte, 6N, 3S, and to distinguish it from taphite or magnesiotaphyte, 2N, 2S, which many recognize by their specific inclusions. If you want to find these crystals, you have to read a lot of text and look at a lot of photographs from studies and scientific papers, which are in my opinion the only reliable material. Only then will you easily recognize these crystals in the field, because there are no similar inclusions in birefringent crystals to see. I am a child born in a volcano. The area, the territory, which I have been researching very intensively for the last few years, is geologically unique, and it is specific above all because of the river that has the largest water in the world and a canyon that was apparently created by enormous tectonic activity and the clearly visible flow of a large amount of petrified lava today, which the entire canyon is pierced with, but in my opinion also the fall of a larger mediatite, or 5 of its large parts, precisely in the part of the canyon that at that time was in the liquid or semi-liquid phase of the formation of the Earth's crust. My door is open with crystals for health, happiness, money and prosperity. I am not from South America, I am not from Africa, India, Madagascar, or Sri Lanka. I am a child born in a volcano. I sleep under the happy stars, meteorites and jewels love me. I don't look for them, they call me and I go there. When I get there, they call me and I pick them up, because my destiny, karma and personal identity that I have carried since childhood are simply fulfilled in this way. Precious stones, the most precious and rarest, can be found according to stories in only a few places in the world. These are areas of volcanic mountains. But what if there is an area on Earth and a volcanic mountain with a very turbulent tectonic past, which is clearly visible to everyone right away? You can clearly see that in ancient times it was a very active volcanic mountain because it is full of petrified lava that flowed and petrified, and you can clearly see the dark gray, very fertile soil in a wide area around the mountain, which comes from volcanic ash. But that is not the end of the surprises. What if that same area is evidently, clearly visible, today with the help of Google Earth, was hit by a large meteorite that broke into 5 parts or maybe even 5 smaller meteorites? It was here that I found the largest and most beautiful gemstones, minerals and meteorites ever found in the world. What if I could prove it, and if I still find the highest quality and rarest gems in the world here every day? But I am not in Mogok, or in South America, or in Madagascar or Sri Lanka. Every piece of information I have stated here with full responsibility is completely accurate, and it is clear to everyone that it is worth a fortune. I am a child born in a volcano, I sleep under the glow of lucky stars, I bathe with bears and wake up to the quiet whisper of a fast mountain river. I offer you prestige and a #1 place on the world gemstone scene. My gems are in many ways the best in the world right now. Of course, only if I am right about everything I have stated here, and there is a very small chance that I am wrong. All interested passionate, serious collectors and scientists can contact me via email, birkjsn@gmail.com.